So here's an example of a more algebraic word problem. The hours of daylight in Seattle oscillate from a low of 8.5 hours in January to a high of 16 hours in July. When will there be more than 14 hours of daylight? So first of all, we read the words. Do we understand what's happening? Well, in the wintertime, there's less sun, and in the summertime, there's more sun because of how the planet orbits the sun and things like that. So that part is not too bad. Now we need to draw a picture. But what does a picture of this look like? In this case, we're representing information. So this isn't geometric information. This is just information. So we have in January, let's put January here, there's a low of 8.5, and then somewhere in July, we have a high of 16. And the amount of sunlight oscillates and goes back down again, and then the next January it repeats. So here's our picture. What's the problem asking of us? Well, it's asking us, when will there be more than 14 hours of daylight? So 14 is around here. We are interested in this date and this date because that marks the beginning and the end of when there will be at least 14 hours of daylight. And so this is our setup, and here's our picture. What do we need to do from here? Well, in this case, we need to create what's known as a mathematical model, a formula that represents this shape right here. Now, there are a couple things we have to do with this. We'll start off with some of the basic stuff first, which is find the midline, because we've done this before. We have some sort of sinusoidal function. We need to find the midlines. We got to figure out where this middle is. Well, to find the midline, to find the midpoint between two different numbers, you actually add them up and divide by 2. You take their average. So 16 plus 8.5 over 2, this is going to be 24.5 over 2, which turns out to be 12.25. So that's our midline. Another thing we can get is the amplitude. The amplitude, remember, is the distance from the midline to either the peak, the maximum value here, or the valley, the minimum value there. We'll use the maximum value, so the amplitude is going to be 16 minus 12.25, which turns out to be 3.75. So this is the easy part. Find the midline, find the amplitude. The next part's a little bit trickier because we have to make some decisions. The things we need are the period, and we need to figure out whether there's going to be a horizontal shift to this. I've drawn it here with January right at the start so that January can be considered as time t equals 0. And since this problem is working in months, we can then figure out what July is. Now, a common mistake at this point is to think, well, July is the 7th month, so July is 7. But that's not quite how this works. If January is 0, then February is 1, and March is 2. So everything's offset by 1 in order to get this to start at 0. If we did start with January equal to 1, then there would be a horizontal shift term that we'd have to deal with. But as we've got things set up, July actually is going to be 6, and then the next January will be 12. Okay, so now we have our numbering. So this tells us that our period is going to be 12 months from this side to that side. That's the length of the period. So, period is 12, and we have this in months. And then we set it up so that 0 happens, so that January happens at 0, so the bottom happens right at the t equals 0 point, and so there's going to be no shift, no horizontal shift. And we have to take this information and put it together into a formula. And so that's the next step. So what is that formula going to look like? Which function starts from the bottom and goes back to the top and back to the bottom again? Well, if you're thinking about it for a little bit, you should be able to recognize, okay, well, it's actually a negative cosine function. If a cosine function would start at the top and go down and go up, but because it's starting from the bottom, it's been flipped over. And so our function is going to look something like y equals negative something cosine something something something. Right? So this is our start. What goes where? Well, we have the amplitude of 3.75. The amplitude goes there. We have our midline at 12.25. That goes on the outside here. And this would be a b times t minus c, but since there's no horizontal shift, it's just going to be b times t. But that b value is not the period. You might remember that the period is equal to 2 pi over b, which means that b is equal to 2 pi over the period. And since the period is 12 months, we'll just think about the number 12. 2 pi over 12 months becomes pi over 6. So pi over 6t. So far, this is the setup that we have. This is one of those moments where students might look at this and say, okay, here's my answer. But here's the question. Did we answer the question? We haven't. We still have more work to do. So I'm going to clear this off and give myself some space. So here's our equation. Y equals negative 3.75 cosine of pi over 6t plus 12.25. And this is the graph. Remember, we're looking for when there are more than 14 hours of sunlight in the day. So we're going to set this and set it equal to 14. And our goal will be to solve for t. In order to solve for t, we need to isolate the cosine term. So we're going to start off by subtracting 12.25 from both sides. And we're going to divide both sides by negative 3.75. And we're also going to switch the order too. Cosine of pi over 6t is equal to 1.75 over negative 3.75. Now at this point, we have a basic trigonometric equation. Cosine of an angle equals a number. Let's take a look. Cosine is the x-coordinate, so we have a negative x-coordinate, and so there should be a solution in the second quadrant and a solution in the third quadrant. When we take the inverse cosine of this, we're going to get that second quadrant value, and we're going to have to use that to get the third quadrant value. So for this, we're going to just plug it into an equation, plug into a calculator. Pi over 6 times t is equal to, if we do the inverse cosine of that, we get 2.0563. Now you can see that this is going to be in radians. In this case, there's no particular reason to be working in degrees. So we have radians. And that's this measure right here. Our goal is to find the other one. And so this other angle is 2 pi minus 2.0563. So 2 pi minus 2.0563. If you put that in the calculator, you'll get 4.2269. We haven't yet solved for t, so we multiply both of these by 6 and divide by pi. We get these two values. T equals, for the top one, it will be 3.9272, and for the bottom one, it will be 8.0728. What does this mean? Did we answer the question? When will there be more than 14 hours of daylight? Saying t equals 3.927 and saying t equals 8.07, this doesn't answer the question. So we need to go back and think about what is the meaning of these values. Well, remember that when we set things up, January corresponded to 0, and February corresponded to 1. And so we just have to work our way through the months to figure out what t equals 4 is going to look like. So March is 2, April is 3, May is 4. And so this tells us right around the beginning of May is when this starts. And this goes on all the way until we get to 8. So May is 4, June is 5, July is 6, August is 7, and September is 8. And so the answer to the question, when will there be more than 14 hours of sunlight? Roughly between May and September. There will be 14 hours daylight from May to September. And that answers the question. So here's another example. A Ferris wheel is 20 meters in diameter and boarded from a platform 2 meters above the ground. The low point of the ride is level with the platform, and it takes 6 minutes to complete one revolution. How many minutes per loop is the ride above 13 meters? This problem has a lot of words, and so what we need to do is we need to read it carefully and draw a picture to make sure we really understand all the bits and pieces. A Ferris wheel is 20 meters in diameter. So here's our Ferris wheel, and we have a 20-meter diameter. It's boarded from a platform 2 meters above the ground, and the low point of the ride is level with the platform. So here's our picture. Here's our Ferris wheel. There's our 2 meters for the platform. It takes 6 minutes to complete one revolution. 6 minutes per revolution. how many minutes per loop is the ride above 13 meters? So we have to go think about where's 13 meters from the ground. Well, we have a diameter of 20 meters, so that means the radius is 10 meters. 2 plus 10 is 12, so it's just above the center. So here's 13 meters. Here's the full picture with all the information written down. We now have to translate this into our model. This is where the graph is going to be that models the behavior of a passenger on a ride. It's going to go low to high to low. So low to high to low. Where's the low? Well, the low is going to be 2 meters. The high, because this is a 20 meter diameter, is the 2 meters plus the 20, so it's 22 meters. And we are interested in where it crosses over 13 meters. Okay, well, just like with the previous one, we now have a graph. We need to come up with an equation for the graph. So y equals, what do we need to think about? Well, our midline. The midline is going to be at the center of the Ferris wheel, which is going to be 10 above the platform, so it's going to be 12. Our amplitude is going to be 10, because from the center to the top or center to the bottom is going to be 10, so 12 to 22 or 12 to 2. And they're going to have a graph that starts from the bottom, so it's going to be a negative cosine. And we have our amplitude was 10, so negative 10 cosine something. The midline was 12, so this will be a plus 12. And now we need to figure out that b value. And again, remember, the b value is not the same as the period. We use the period to get it, but they're not the same thing. So in this problem, what is the period? How long does it take to go around one full loop? Well, 6 minutes. And so that is our period. Our b value is 2 pi over the period, which would be 2 pi over 6, which reduces to pi over 3. So pi over 3t. The model of the height of the rider is y equals negative 10 cosine pi over 3t plus 12. And just like with the last one, we're going to need to solve for this to figure out what times the passenger will be at 13 meters of height. So just with last time, we're going to substitute in our value. In this case, it's 13. Negative 10 cosine pi over 3t plus 12. And we need to isolate the cosine terms, so we're going to subtract. One is negative 10 cosine pi over 3t. Divide both sides by negative 10. And at this point, we're also going to swap the sides. Once we get to this point, negative 1/10 is not one of our known values, so we're going to have to use the calculator. And when we do that, we also need to think about where we are in the picture. So in our unit circle picture, cosine is the x-coordinate and it's negative. So it looks like this. And so we have a solution in quadrant 2 and a solution in quadrant 3. Plugging this into the calculator, when we take the inverse cosine of 1/10, we are going to get 1.6709. And that corresponds to this angle right there. So the other angle is going to be 2 pi minus that amount. 2 pi minus 1.6709, which when we put that into a calculator, we get 4.6123. And lastly, for this part, we need to solve for t by multiplying by 3 and dividing by pi. And this gets us two values, 1.5956 and 4.044. Okay, we've now done this calculation, gotten these two values. Did we answer the question? The question asks us how many minutes per loop is the ride above 13 meters? And we need to think about what these two values represent. Well, the 1.5 value, 1.6 value is this one here, and the 4.0 value is over here. And so we are interested in the amount of time that elapses from this point to that point. So we're trying to find the distance between 2 points on that number line on the x-axis, and so we're going to have to take the difference. So time above 13 meters, we're going to have to do the difference. So 4.044 minus 1.5956. Put that in the calculator, we get 2.45. Be very careful. This does not say 2 minutes and 45 seconds. This says 2.45 minutes. If we wanted to convert this to seconds, to minutes and seconds, we take the 0.45 and multiply by 60 because there's 60 seconds per minute, and that would give us 2 minutes and 27 seconds. So again, what did we have to do? We had to understand enough about the picture to create this graph that represents the height of the person. And then once we have the graph, we get the equation. From the equation, we solve for t. And then from this information, we had to determine how to answer the question. So a lot of steps, but if you go slowly and carefully through it, you should be able to follow what's happening, and you should be able to do it for yourself.